Hi. So before we debug what is wrong with this code, we first need to understand something else. Something that is very specific to how threads work on your hardware. Okay. So guys, let me give you some idea in terms of how these threads perform certain operations whenever they are scheduled on a certain CPU core. So we know that our machine may have multiple CPU cores. So let's say a certain thread, let's call it thread 1, that got scheduled on CPU core 1. Now, when that has happened, what that thread will do is that it will create copy of the variable that it has to transform. So there is a current variable. This current variable is residing in our main memory, let's say in our RAM. So this thread will create a copy of this current and have that copy reside in the local CPU. Why it does that is because of performance reason. Because if certain variable isn't, it's very quick to read it. It's very quick to modify it. Okay. So let's say that thread has created a copy of current and it has made changes to that current. Okay. And then the job of the thread is done. Now your system from time to time, it flushes everything back to the main memory. So if there were certain threads that had copied certain variables from main memory, made changes in them, then your system from time to time flushes those changes back into the RAM so that it's visible to other threads. But it poses a great risk. What if when a certain thread has made change inside this current and that change has still not been flushed back into the main memory? If it has not been flushed back into the main memory, other threads which are trying to read the value of current will not find it updated, will find it to be the same old value. This problem is called as the problem of memory visibility. So the second danger of concurrency is memory visibility. There are no guarantees about the fact that if a thread has changed a certain variable, then that change will be reflected to the other thread also. There is no guarantee to it basically. Why? We understand that because of this reason. Okay, so here also the exactly same thing would have got happened. So you can see that when thread 1 was scheduled, thread 1 changed the value of current to 2 and that luckily got flushed to the RAM. So my thread 2 was able to see that change. But now my thread 2, when it created a copy of current inside its local CPU and added 1 to it, the value of current became 3, but it is not visible to the other threads because it would not have been flushed back to the main memory. Okay, and at times it just takes lots of time for these changes to be flushed back to the main memory. So till that time, your program would just be halted. So can you imagine what is the scenario that got happened here? While the other threads are running their run method, they find themselves stuck inside their while loop. Why? Because the current is still equals to 2. The current value that was supposed to be made 3, it has been made so by the second thread, but it is currently residing inside the local CPU only. That is the reason other threads are not able to detect it and they are still stuck inside their respective while loops. So this is the problem of memory visibility. Now, what is the way to deal with memory visibility? So languages offer a keyword that you can associate with such a shared variable. So that keyword is called as volatile. You might have heard of it. So when you make a certain variable as volatile, then any writes that are done on top of this variable is immediately flushed back to the main memory, so that there is no memory visibility problem of variable across the different threads. So if I just kill this and run this program over and over again, you will see that you will never end up landing into the same memory visibility issue again. So I have just ran it and the output is as expected from 1 to 10. You can probably run it again. In fact, you can run it several times to just convince yourself that merely by changing this variable to volatile, the job got done. Okay, so keep it in your mind. With threads, if there are certain shared variables, then the problem of memory visibility can be there. The change made by one thread may not be visible to other threads. See, we have run a lot of programs by now, and this memory visibility problem has been encountered probably for the first time. So, in the previous occasions, we were all lucky. It's non-deterministic, right? Sometimes it can happen, sometimes it cannot happen. But the way to deal with that is to make that variable volatile. Okay, one more thing. Let me tell you, these days, whenever you read the programs written by engineers working for industries, they very rarely use keywords like volatile because there are alternate ways of taking care of memory visibility. I'll be talking about what those alternate ways are, but now probably you understand why this volatile keyword has been placed in languages and what is the role of that. So let us be very clear about the difference between the first danger and second danger. The first danger was about race condition, which happens when there are multiple threads that are trying to update the same variable. Okay. This problem is of memory visibility, which can happen even if you have, let's say, one reader thread and one writer thread. So let's say there is only one writer thread, which is changing the value of current. And then there is a reader thread, which is reading the value of current. So in this scenario, we don't have multiple threads that are mutating the same variable. We only have one thread. So race condition will not happen here, but memory visibility issue can happen here, right? Because the change made by the writer might not be visible to reader. Okay, so the second danger is very much different from the first danger. Okay, so in the upcoming time, I'll tell you that apart from volatile keyword, what is some other way in which we can take care of memory visibility issues.